key can have attributes that does not impart any uniqueness or distinguishability in your keys, right? We can
Okay.
have a minimal set of attributes in a super key that can be used to distinguish between tuples, and that is basically what we call a candidate key.
Great. Thank you.
Can, and candidate keys are basically candidates for a primary key.
Is a foreign key same as a candidate key?
No, a foreign key is essentially primary keys which are part of some other table. So essentially a foreign key is used to relate to other tables using their
Okay.
primary keys. Any other questions? Okay. So we did what did we do? We did select, we did project, we did Cartesian product, we did union. Okay. Next is the rename operation. So rename is essentially the result of relational operations. However, remember that our relational models or our relations that we have, the tables, they are named. For example, the account relation, the customer relation, blah, 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 borrower, loan, what have you. But when we perform an operation, let's say I performed a select operation on a particular table, that results in some particular relation, but that particular relation does not have a name, right? So that is some temporary relation that is being generated. But we can sort of use, so remember that that particular resultant relation will not persist across your queries. So if you have one query that creates a select operation, however, we want to use that particular result in another query later, that particular operation is not there yet. We will talk about the assign operation later, but essentially what we have learned so far, that does not exist because that does not persist. Even apart from that, we even might sometimes want to rename the resultant relations of our queries within the same query. So for that, we would use something called a rename operation. Note that the rename operation looks like a small case p, but it is actually the Greek character rho. So rho for rename. And essentially it says that given a attribute or given a relation schema, we would like to rename it to X, right? So there are certain reasons for doing this. We will cover some of those reasons shortly, but essentially the input schema for this rename operation is going to be the schema E, and the output resultant schema of this operation is again going to be the same set of attributes that is in E, but with a different name, right? So essentially it allows us to rename a particular schema into something else, and essentially allows us to rename their attributes as well. Now, why would we want this? So um, oh, right, I need to talk about it. So, so the rename operation rho only applies to a particular specific relational algebra expression. Remember one thing, that renaming a particular relation does not create a new relational variable for you, right? It is just renaming it to something or naming or providing an alias for that particular relation. It is not going to create a new variable and save the resultant data somewhere, right? So think of it as a pointer to the result, not the actual variable, right? So a relation operation is mainly used for two purposes. It allows a derived relation and its attributes to be referred by a different name by enclosing them into different operations. So if we have multiple composed operations and somewhere down the line we compute something, we can rename it and use it in the same operation somewhere else. And another main use of renaming relations are, maybe sometimes we want to uh, cross our relation with itself, right? So let's say that I want to perform the relation R cross R. Well, that does not make sense in terms of set theory. However, we can use the rename operator to rename R to S. That is what this one does here. We are renaming our relation into S, and then we are performing R cross S. So in other words, basically the rename operation is used to resolve ambiguities in when we are using relational expressions, right? So, can anybody think of any reason why I might want to perform a cross product of this table with itself? Anything that comes to mind? So, for example, let's say that why would I want to perform loan cross loan, for example? What would loan cross loan look like in the first place? L41 San Francisco 7,500, and followed by that L445 Los Angeles 2000, L437 Las Vegas 4300, L419 Seattle 2900. Then the next set of values come. So that is a cross operation, right? So why would I want something like that? No clues?
Maybe you're interested in having all of the values in every way possible within that same table.
Yes, exactly. We want that, but why would we want something like that? So essentially, we use this sort of an operation where we cross something with itself is to compare something with other columns in the other rows in the same table, right? So let's have an example. So let's say that I want to find the ID of the loan with the largest amount, right? So given the loan table, I just want the loan ID which has the largest amount. Now, for those of you who already know SQL will say that I can always use the aggregate operation max and get the largest amount from there. And it is much easier. However, the main reason for having this fundamental set of operations is that we can sort of use these fundamental operations to find those or create those aggregate operations as well. It does not look nice. Most of the time it looks really gross, but we can if we want it. That is one way of thinking about it. So mathematically speaking, just given those set of operations, we can find the maximum value. And in this particular scenario, this becomes one of those problems, right? Where how we do it becomes really unintuitive, right? We have no clear indication as to how do I get the maximum value of a loan amount and the loan ID with the maximum amount, right? So basically we want the answer for this one. So basically this particular loan ID, but how do I get that? Well, instead of directly looking for the maximum value, we can look for the opposite of that, right? So we can find all loans that have an amount smaller than some other loan, right? And then once we have those set of values, we can just use set difference to get the largest loan number. So how would that work? So we can say that we can find the Cartesian product with loan itself. So basically, in order to do that, we would use the rename operation. So let's rename loan to test and perform the Cartesian product with loan itself, right? So now that gives us a list of tuples where now we have what? Branch name, amount, loan.loan ID, test.loan ID, test.branch name, test.amount, right? So loan.branch name, loan.amount, loan.loan ID, test.branch name, test.amount, test.loan ID, right? So all possible combinations. From there, the main important thing that we need to note is it would have all possible combinations of all possible loan amounts. So 7,500 will also have a corresponding value for 7,500, 2,000, 4,300, 2,900, right? Then 2,000 will also have the possible combinations for all of them, right? Okay. So from this particular cross product, we can then say that once we have this, get me all the tuples where the loan.loan amount is less than test.loan amount. So get me all the tuples where my particular loan is less than some other loan in this entire table, right? So essentially it will, if there is, and you might say that that would result in a bunch of rows, bunch of tuples, and that is fine. It's a set operation, right? So it can give you 20 different rows. That is totally fine. But remember that now if we select that particular set of tuples, it means that my particular loan amount is less than some other person's loan amount, right? So from there, we can then project out the loan ID from that particular list. And that would give me a list of loan IDs whose loans are at least, less than some other amount in my table. So does everyone see the thing here where only the loan amount, only the loan ID which has the maximum loan amount will fail this particular condition, right? Because it will not be less than any possible combination across all values. Does everyone agree? That this will get me a list of loan IDs that have loans that are at least less than some other loan amount in my table.
I get most of this, but at the very end of that statement where your mouse is right now, what is that? What does that mean? The P test loan?
That is the rename operation, right? So we are renaming loan to test, right? Because we cannot perform loan cross loan. That is something not allowed in set theory. So basically we have to rename loan to test, and then we are basically performing loan cross test.
So you're just crossing loan with itself then, right?
Yes, we are crossing loan with itself.
Okay,
but
so then where do we get the test amount from? So you have loan dot amount is less than test dot amount?
Yes, but remember the test is a copy of loan. So if we cross those two together, we are going to have 6 attributes. That is loan.loan ID, loan.branch name, loan.amount, test.loan ID, test.branch name, test.amount.
Okay. Okay.
Right? Which is going to be a cross across itself that has all possible combinations with itself.
Okay.
Right? Any other questions? So does everyone agree that with this particular select operation, I get tuples for which my loan amount is less than at least some other loan amount in the table? And basically, I'm selecting the loan IDs from those sets of loan amounts. So this entire...
I see what you're doing. Okay.
Right?
Okay, I got it. Thank you.
You're welcome. So this gets us the sets of tuples where my loan is less than some other loan amount. The only case where this will not return a tuple is for the maximum value, because the maximum value across all possible combinations, even with itself, will not be less than the other test amount, right? So now basically what we do is just perform the set difference. So project the loan ID for all loan values, subtract out the list of loans that are less than some other loans, and basically we end up with the loan ID that has the maximum value. So we just guess a random loan amount that it should be less than. No, Taha, we are actually comparing across this entire table of loan amounts. Okay, so let's see. Okay, so let's say that I have 2 attributes. Let's say ID and let's say amount, right? So let's say I have ID 1, 2, and 3. I have amounts 100, 200, let's call it, yeah, and let's have 50, right? So this is our relation that has these values. So let's call this the loan table, and if we perform loan cross loan, remember we cannot do that. That is why we are renaming loan to test and basically then crossing itself with itself. So what is the result of this operation? Can someone type out in the chat window? What will be the result of this particular cross product or Cartesian product? Let's call this as the loan.
Was that a trick question because you can't cross something with itself? Because you didn't rename